Today we're talking about histograms. Frequency histograms are a way to display data similar to a bar graph, except the bars have to be touching each other, okay? So if the bars are not touching when you draw this, you'll get points off. Also, if your bars aren't drawn with a ruler, if they look hand-drawn, they will take off points, okay? So they are very picky. Also, like in science, you had this little thing here. I'm going to draw over it. What is that thing called? Anybody know? It's called a break in the graph. A break means that we did not start at 0. Very rarely are you going to start at 0. So for this one, test grades, thank God there was no test grades that were at 0, right? The lowest was in the range of 41 to 50. Okay. You cannot, like they said up there, have any spaces except if there's a 0. Then obviously there'd be no bar there. You have to have a label on your x-axis and on your y-axis. This also, you can sometimes see the word intervals here because those are their intervals. The intervals also must be evenly spaced. Okay. So if I were to have a chart for this one, it would have intervals here and the word frequency here. And usually these are tally charts. So you'd have 41 to 50 and 51 to 60. So they'll give you a list of scores, 61 to 70. Here there was 3 kids, so you do those 3 little slash marks, you remember that? And here there was 0 kids in that one. There was 1, 2, 3, 4 kids in this one. You take your tallies, and then you make your bar graphs from those tallies. Okay? Like I said, this is the easier table to work on. If you get this one, that's a good one. These usually have, one is up, one is down. The next one we're going to look at, it looks like stairs. So how many test papers did the teacher mark? You have to show work on all questions. So you have to tell me, okay, there was 3 here. There was 4 here, 11, 8, and 6. And then down here you have to show me how you got that. 3 plus 4 plus 11 plus 8 plus 6. Go ahead, add that up and tell me how many test papers. What is it? 32. So you 32 what? You always have to label it. 32 papers or 32 kids who took the test that she graded. I would say this one is a little tricky question too. B and D are the toughest ones here. All right. Which interval contains the median? So if I lined all these children up from the kid that got the lowest grade over there by Mrs. Pelkey to all the way over here, this is the kid that had the highest grade. The kid that got the middle is the one that's is halfway in between. Okay, so if there's 32 kids and I do 32 divided by 2, who can do that in their head? I want the 16th kid. How do I find the 16th kid? Well, I can either go from the top or the bottom. Remember, it's the middle. It's going to, either if I count from the top or the bottom, I'm going to find the 16th kid. So here's kid number 1, 2, 3, 4, 5, 6, 7. 7 plus 11 is what? If I go to the next one. 18. So 7, I'm looking for the 16th kid. Isn't that 16th kid going to be here? Because I have up to the 18th kid here. I have a kid number 8 to kid number 18 in this group. So of course, right here, the 16th kid is going to fall between 71 and 80. Within what range did most students score? Most, again, is the what? Another word for most is the mode. And here I'm looking for my highest bar. And my highest bar, again, just happens to be 71 to 80. 11 kids. Now, for this one, you must know this formula over here. So I'm just going to make a little space over here. In middle school and in high school and in college you really have to commit to memory these two formulas. Percent over 100 equals is over of, or percent over 100 equals part over whole. When you're doing a percentage problem or a percentage word problem, it's either going to be like, you know, you're going to either see the words is of, or you're going to have a part and a whole. In these questions, it's going to be part over whole. You have to memorize those formulas, okay? You will use them when you're talking about your car loan, your student loan, your mortgage loan someday, those type of things. When you talk about taxes on things that you're buying, that's always a percentage. Okay, I want the percentage of students who scored more than a 70. More than a 70 are going to be the kids here, here, and here. So it's 11 plus 8 plus 6. That's 25 kids altogether. So I'm going to use my formula. I'm going to say x over 100. The part of the kids that scored above a 70 was 25. The total number of kids is 32. And then we're going to just cross multiply and divide. You guys remember that? 32x equals 2500. Then divide both sides by 32. X equals, it did not tell you to round, so go ahead and divide that and tell me what the percentage is there. $2,500 divided by 32, anybody? $78.125, I think. Percent. It did not tell you to round, so if you round it, you will get it wrong. Okay, do you guys, all this come back to you guys remember this from science in middle school? Actually, on your DBQ, sometimes they'll give you histograms, right? For social studies, you'll get, yeah. All right, now this is the tricky one. This is called a cumulative frequency histogram. What does the word cumulative mean? Adding. It means adding. If I wanted to say what is the cumulative rainfall for the week, which they're really looking at, right? Because what's happening this week, do you think? It's raining a lot, so I want to know the total number, and they put people on alert because of all the flooding and other issues that come with that. So cumulative means I added everything up. Now, if I added all my columns together, so this is 50 to 99 yards, 50 to 149 yards, 50 to 199 yards, 50 to 249, 50 to 299. Okay, this is yards, distances swimmers completed in a recent swim test. Okay, which the title should be there. Swim test. Okay. You do not have to do this, but the best way to do this problem is to try to break this down to one of those regular charts we had on the previous page. So I'm going to help you do that. Now, swimmers, does anybody here a swimmer? So 50 yards means you're going back, you're going to go down and back one time. Okay? That's one lap, down and back. So this is 1 lap to 2 laps. Okay? That's a lot for some people to do down and back, right? 2 times, that's a lot. This is up to 6 laps here. So this is 300 yards. That's 6 times down, 6 times back. Okay? So let's do 50 to 99 yards. So 1 to 2 laps. Now, my next interval is going to start at 100 and go to 149. So this is 2 to 3 laps. Then I go one more than 149, which is 150. And then it's going to end at 199 laps. Go up 1 from 199, and that's 200 to 249 laps. Up 1 from 249 is 250. And that's going to 299 yards. I think I said laps before, yards. So if I added every interval, to go backwards, what's the opposite of adding? Subtracting. So what I'm going to do is I'm going to start at my last bar. My last bar is always my total. This is always my total. So the total number of kids that competed here, if I look up here, the total is 20. That's all the kids that swam 50 to from 1 lap to 6 laps. So to figure out the kids that just did 5 to 6 laps, I'm going to take this and I'm going to subtract out all the kids that did less. So 20 minus the bar before, 20 minus 15 is 5. So 5 kids swam the 5 to 6 laps. Now, if I want to do this one right here, I'm going to, again, subtract out the ones that were lower than that. So if I want the 200 to 249, I'm going to subtract out all the ones before. The ones before were 12. So this is going to be 15. Take away 12, which will give us 3. So 3 kids swam 200 to 249. So 4 to 5 laps. Right? This is 4 to 5 laps. All right, so the next one is 12. But if I subtract out the bar before it, 12 minus 12 is 0. There was no kids that swam between 150 and 199. This one is still 12. I'm going to subtract out the one before, so 12 minus 7 is 5. So 5 kids swam 100 to 149. And this one here, this last one, is always exactly what it is. That's 7. So 7 kids swam between 50 and 199, or 1 to 2 laps. Doesn't it make sense that most kids swam this, right? So suppose this was a lifeguard test, which one of my kids is a lifeguard. He said that when he went to his lifeguard training, there was about 30 kids. Within 5 minutes, he said half were gone. Why do you think that? They had to swim 8 laps, and they were done right about here. It took them 5 minutes to go one back and down, and they couldn't go back again, right? So even though you're a really good swimmer, like say, oh, I swim really well in my parents' pool, I swim, at camp a lot. But to be a swimmer, you got to swim, you got to be able to do those 8 to 10 laps in a row without stopping. And that was what he had to do to become a lifeguard. That's a 7. 7. That was right here. See 7 right here? Yeah, sorry. That's a 7. So yeah, then within, he said about, 5 minutes, there was half the kids that were gone. When I picked him up, there was only 5 kids left out of 30. Because you had to pass all these different parts of the test. All right. Based on the cumulative frequency histogram. Now, if you do this, then the questions will be much easier to answer. Based on the cumulative frequency histogram, determine the number of swimmers who swam between 200 and 249. Now you can just go right up to your chart. 3, but you got to label it. I'm going to put kids. You could put swimmers. If you don't label it, you'll get it wrong. That's why we push you guys to do complete sentences. And the number of swimmers who did 150 to 199, that's going to be 0 kids, looking up at our chart. How many kids took the swim test again? 20. And if I add up all these numbers here, my total should be 20, and it is, if I add all those numbers up that we just did up there. How many swam more than 199 yards? Well, then I have to add these two together, the 3 and the 5, so that's going to give me 8 kids. And what 10-yard frequency interval of distances did most swim? Again, most means the mode. And if I go up there, the most, remember, was the very first one. There was 7 kids. That was 50 to 99 yards. Of course, that's the easiest one. So most kids can do the easiest one, right? Yes? so now we're going to be talking about scatterplots. Scatterplots are really interesting, I think, because they talk about how are things related? Are they just correlated, which means, does one thing kind of go with the other, or did one thing cause the other? So this is talking about hours spent watching TV and test scores. Do you think that hours spent watching TV, what did it say that it did to the test scores? Right. Is that true? Do you think that, spending time watching TV or your cell phone really now, that's basically, does that really cause your test scores to go down? It could be, it's a possibility, but we can't say 100% that it caused it, right? We can't say that watching TV. Now, so it's correlated, but we can't say one thing caused the other. All right, so what I drew right now is called a trend line. A trend line, there's 3 different words that's going to go with trend line. The first thing, so we're going to write them over here. It's also called a line of best fit. I'll talk about that in a minute. And we label that line with something called a correlation coefficient. Correlation coefficient is also called the R part. So it'll be labeled R equals something. And it's kind of like the slope of that line. Well, the slope of a straight diagonal line is usually either up 1 over 1 or down 1 over 1, right? If I use this line here, down 1 over 1, it kind of looks like down 1 over 1, down 1 over 1, okay? The line of best fit means I'm going to draw a line that half the points will be on top, half the points will be on the bottom, and try not to go through any of them. Usually you'll go through a couple anyways. Let's see if it worked here. 1, 2, 3, 4, 5 on the bottom. 1, 2, 3, 4, 5, 6 on the top, and I went through 2. That's not too bad. Now, your R value or your correlation coefficient, how well those two things are correlated, is by how tight those points are to that line. If they're really close, the closer they are to the line, the closer the correlation coefficient is to 1. I'm going to call this R value or correlation coefficient negative 0.82. That means I kind of talk about it as money, like 82 cents is close to $1. Those points are close. Okay. Now I could have called it negative 0.84, negative 0.87. You just have to come up with a guesstimate of what that R value is going to be. So we said that these two things are correlated, but we couldn't say that one thing caused the other. So what are some things that are causal? Well, if it rains today, which it is, the grass is going to grow. Is that correlated or is that caused? Does the rain cause the grass? It's caused, right? How about rain and the level of water in your backyard or the lake? Well, right, because if you had a swimming pool there, then it could be correlated because you could always have water in your backyard if you have a swimming pool. But if the water levels, or if it rains, isn't the water level going up in the lake? Okay, so those two things are caused, the level of the water, right? What about French fry sales and the Olympics? When the Olympics are on, French fry sales go down. Is that true? Do you think that happens?
No, they go up.
They do the monopoly thing to get people to increase their sales, right? But why do you think French fry sales do go down during Olympics?
The Olympics,
Go ahead, Seth. Why?
the Olympics are a
Uh-huh. Right. People want to eat healthier, right?
All those athletes like, like that, they don't eat McDonald's.
They don't eat McDonald's. So, can we say that the Olympics caused McDonald's sales to go down? No. We can say that it's correlated, but we can't say that one thing caused the other. It could be that it's just the summer. Do people really eat French fries in the summer?
Yes.
Well, it's a hot food. If you go to McDonald's, are you going to get a shake in the summer, or are you going to get French fries?
Shake.
You're going to have both, and you're going to put the French fries in the shake, right?
True.
Yeah, okay.
Only chocolate.
Not in the vanilla shake.
Vanilla.
Okay. So that throws my theory all out the window. But I really don't buy my kids as many fries in the summertime, honestly. They want things that are cold.
4th of July, Jimmy loves like burger and fries.
On the 4th of July? Okay. So we have to understand the difference
Maybe
between...
a hot dog.
Yeah, a hot dog would be better. The difference between causation, one thing definitely caused the other, okay? Not studying and your test grade, that not studying causes your test grade to go down. That's something that's caused. So the next thing we're going to talk about is these lines of best fit again. Here are two examples or trend lines. They drew them in for you. This one again is going down, so it's a negative. I would estimate the correlation coefficient here to be a negative 0.78. Could you say 0.80, negative 0.80? Sure. This is a positive one. It's going up. I would say the correlation coefficient there is 0.82. I think these are a little closer than that one. Okay. Again, it's a guesstimate. So here there's three examples. We're going to practice drawing the trend lines and estimating what their value may be. So this one, if I try to, usually the faster you go, the better it is for me. Let's see how I did there. 1, 2, 3 below, 1, 2, 3, 4 above, and I kind of went through 2. So this is a positive correlation. It's the line's going up. I'll call this one again 0.84. I could say 0.86. I could say 0.87. I could have said 0.79. Somewhere close. They're close. They could be closer, right? See this next one. I'm going to try to draw this one pretty fast. I have 1, 2, 3, 4, 5 on the top, 1, 2, 3 on the bottom. I could have been a little bit better on that one. I should have gone a little higher, so let me try it again. One, 2, 3, 4, 5 on the top. 1, 2, 3, 4, 5 on the bottom. A little bit better on that one. This is a negative correlation. So I'll call this R value negative 74 cents or 0.74. I think those are a little bit farther away than the other ones were. Now this one, I could draw a trend line going up, right? Does that look right to you? I've got 1, 2, 3, 4, 5, 6 on the bottom, 1, 2, 3, 4 on the top. That one looks like it's going up to me, but it also looks like it could go down, right? Couldn't I draw one this way? I could. If you can't figure out which way to draw your line, this is called no correlation. You could have an R value of 0, or you could say, we'll see sometimes rounded to the nearest hundred, 0.021. That's like a little over 2 cents, right? Or I could say that R equals negative 0.04. Okay? So a really small number, or you could have 0. All right. So let's try these. If you get confused with the word correlation and causation, just underline, was something caused or not caused? Here, I'm looking for something that is not caused. The number of hours worked and how much money. Does your hours work and money, are those two things caused? Yes. The amount of rainfall and the level of water in the lake. We already talked about that one, right? Rainfall causes the water of the lake to go up. So that one is a caused. The increase of warm sunny days and the number of ice cream vendors visible. Do sunny days? No, because people have to sell ice cream on cloudy days too, right? So this one is the answer. The sunny days did not cause the vendors. And the last one, the number of lights left on each day and the amount of the electric bill. Don't your parents yell at you about lights, right? Turn off the lights. Because that one is caused. So those three were caused. This one was not causal. And this one, we are looking for one that is a causal relationship. So one thing that caused the other. Does a child's weight increase her vocabulary? No. A decrease in temperature and the increase in attendance at an ice skating rink? No. You say it's D, the number of minutes spent exercising? It is. Exercising and the amount of calories burned. Now, B could have happened, you know, a decrease in temperature and people all said, oh, let's go ice skating outside today. Yeah, that could have happened. It's correlated, but that doesn't mean one thing caused the other. All right. Number 3 is a tricky question. The more the furnace runs, the warmer the house becomes. Well, I don't know about your house, but my house has a thing called the thermostat. Is it going to, if it's set at 70, is it going to ever get higher than 70?
No.
Yeah, but it's not running it. The furnace is on. Before the furnace is on, there's more running. If it's running, it's going to make your house warmer. It's not going to stay the same temperature.
Right, it's going to make your house warmer.
Yeah, so the warmer the house becomes.
Huh, what do you think on that one, Mrs. Pelkey? I think it's letter C. No, you think it's B? Okay. I would have gone with C, the colder it is outside.
It could be either one. Either one makes sense. The furnace running doesn't cause it to be cold outside.
Yeah, exactly.
Oh, I thought it was opposite. Okay. So now you have